Okay, so I call these type 0 regression questions, okay? Points are provided by the question, okay? So let's just type right at the very top here, regressions, right? So we're going to use a lot of the regressions this year and next year, a lot of it. Okay. So here we go. An airplane performs a stunt at an air show. It consists of a sudden drop followed by a rapid increase in height. The stunt ends when the plane reaches its initial altitude. So if it gets back to where it was at time 0, right? If you get back to that height, then the stunt is over. The story is over for us. The table below shows the heights at different times, right? So you've got time. This is not always going up by 2s. Watch this, 2 and then 6. That goes to 8 and all of a sudden goes to 15. So it doesn't have to be consistent. And so every time has a certain height associated with it. Okay? And I will never trick you on this one. The first row is always your x value. Okay? And the second is your y value. So let's go up here. Just make sure. If you ever get a table like this, right, you're guaranteed that this is x and that's y. If you ever get a table that's horizontal, like that, you're guaranteed that the top is x and the bottom is y. There's no, I'm not going to trick you on that. Even in grade 12, like we never, it's like you don't have to guess, okay? So it says A, determine the equation that models the height of the plane over time. So they want the equation. So we're going to say no problem, L1, L2. And let's type that into our L1 and L2 just like we're saying we will, okay? So you go ahead and do that. And I will do the same. Stat edit, clear whatever you have in there. Just a quick check to make sure I got it right. Trust me, it's very frustrating when you do all the work and you get the wrong answers because you typed in one wrong number. So now we go stat, calculate, quadratic regression, L1, L2, alpha. Oh, I forgot my comma. So comma first, then alpha trace, enter. So let's go ahead and perform that regression. Let's see, how am I doing space-wise? My key will tell me. Okay, we need to be a bit careful with our space here. So I'm just going to do this over here for A, stat, calc, quadratic regression. So next year, you're going to do quadratic, cubic, sine wave. You're going to do a bunch of different ones. So you always have to tell us what regression are you performing. So we're going to write down y is equal to 9.37. Let's use 3 decimals. Why not? 9.375 x squared minus 183.750 x plus 1080.001, right? You know what? Thinking now, I'm just going to do 2 decimals for that last one. That's all right. I don't want this 001. It's just going to be too annoying working with it later. And 2 decimals is fine as well. Okay, because sometimes I give you an equation that has 3 or 4 decimals, so I don't want you to be scared of that. Like, just use whatever I give you. So there we go. That's our, and we know that every single point on this curve will be time and height, okay? So let's get our window figured out, okay? So we're gonna go zoom 6, right? No, not zoom 6. Zoom stat, right? 9. Zoom stat. Sometimes zoom fit will do it. Uh, zoom stat, let's go. What's wrong? It's not doing anything. Zoom stat didn't do anything for me. What do I need to do? Yeah, plot 1. Some of you are saying it, some of you are thinking it. Plot 1 needs to be on, yes. Zoom stat does not do anything unless plot 1 is turned on. Okay, so let's try it again. Perfect. It shows us enough so that now we can change our window. I want to see my y-axis, so I'm going to go to my window. I'm going to go like -5 or something, right? Like I want to see a little bit into the negatives. X max, I'm going to increase that a little bit as well. What do you think, 25? Y min, I usually want to see my x-axis, so I'm going to go -10, something like that. Y max, I should probably be, just think with me here, okay? This is pointing up first and foremost. This is my initial height, right? 1080. So I would want my Y max to be probably in the 1200s or 1100s or something like that. So as I said, zoom stat doesn't solve your problems. It just gets you to a window that you can work with. Hit graph. That's what you should see, something like that. Yeah. You have a window problem? Somebody can ask here. I'm gonna have to talk to my grade 12 things to stop messing around with things. Y and that. Another regression. Run it again. Just gonna change the window real quick here. Now you should be fine from now on. There you go. Completely messed everything up, eh? I'm gonna have to check. I have a record who had that calculator last. I'm gonna find you. All right. So here we have it. We've got our window, so now we can work with the rest. Okay, so what's the initial height of the plane at the start of the stunt? And that would be this, right? At time 0. So for B, the y-intercept gives you that, right? Gives this info, right? And that would be 0 C, right? So for us, it's 0, 1080. And so the height is measured in feet, so you just answer 1080 feet is the initial height. Okay, so it's basically once you come up with the equation, it's back to word problems with the equation, right? How long did the stunt last? Okay, so picture this with me. The stunt starts at time 0, and we're told that it ends when it gets back to the height that you started off with. So watch what we're going to do here. Y2 is equal to what? 1080. That's right. Watch that, right? So this tells me action starts here, it ends here. That's when the modeling is over, right? Like we're not modeling what happens afterwards. So time 0 to time here, right? So we're going to figure out that time there. Second trace intersect. We're going to go closer to that one. Enter, enter, enter. 19.599, that's 19.60, right? So where is that? I'm going to say C here. Y2 is equal to 1080. This is same as initial, right? Initial height. And then we're going to go second trace 5, and we get 19.60 seconds. You can put the coordinate down first and then just tell me seconds, right? Then I know you understand what's happening there. So from time 0 to time 1960, right? So that's how many seconds went by, right? Okay. When was the plane, or what was the lowest height of the plane? That would be my vertex min, right? So let's do that. Some of you are already like ready to go, right? I'm ready to eat, Mr. Direction. I don't want to talk vertex and stuff like that. I don't blame you. Okay, let's just do that, and then I'll stop here, and I'll give you a little bit of homework. Second trace min. So it's a min, not a max. So you used to max all the time, right? It will try to find it, but it will give you the wrong number. So there it is. I'm going to go second trace min, and that is 9.80, 179.63. So we know that after 9.8 seconds, you reach the lowest point of 179.63 feet above ground. Okay, so you would say 179.63 feet is the lowest height that was achieved. Okay, I'm gonna ask you to do the rest for homework, and then we'll continue this tomorrow. Can you do that? I think you can. And one more. Okay, one more. I'll post the key for this. So page 50. Page 50 has another one. Okay, so that's the homework. I'll write that down here. Homework, page 49 and 50. Give that a try. So you should know what the graph looks like. Okay, have a good one, guys. I will see